This is House Planning Help, episode 389. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Es Tresidder from Highland Passive, and we're covering three quite different topics today, all relating in some way to his retrofit project. We're talking air-to-air mini-split heat pumps, also water damage during construction, and using your electric car to power the house in times of need. And we know Ez well because he's been supporting our hub members for the last couple of years, answering their questions on building physics, retrofit, moisture management. And he's been a really good fit for us because he's been around this topic for years, done various training. He's got practical experience too. And like many of us, he knows that there's always something else to learn. And we're in the process of trying to grow our Ask the Expert team. It's tricky because you do want to get it right. And I imagine probably the people we're talking about are already in our network, but I'm trying to locate them. So we're looking for experts in very particular parts of the house building journey. We might be talking a planning consultant or a contract administrator or an engineer and so on and so on. But these people must be doing this day in, day out, in a job already. We're just looking for a few hours or an opportunity to check in with you a couple of times a year. So if that sounds like you want to help people, well, get in touch through the website at houseplanninghelp.com/contact. Let's get to our featured interview with Es Tresidder. He's been on the podcast before, sharing how he upskilled in DIY during his retrofit. We'll make sure we link that into the show notes. And if you haven't heard that episode, probably start there. We're coming back to it today, though, now that the dust has settled, and we'll reflect on a major challenge that he had during construction. The other hot topic will be heating with an air-to-air mini-split heat pump. And why does he like this setup? However, we start today with an unexpected topic. Storm Amy had ripped through the Highlands and Ez was experiencing a power cut. But not all was lost.
We have an electric car that's capable of doing what's called vehicle to load, which means that you can plug an adapter in to where you normally plug it into charge and then plug a 3-pin, normal domestic plug into that and then run that into your house. So you can't power your whole house, but you can take 3 kilowatts from it. So we've currently got that adapter plugged into the car and 3 or 4 extension cables strewn around the house, powering the fridge, freezer and the dishwasher and the Wi-Fi so I can talk to you, charging computers. And we made a loaf of bread overnight, and but that took us a long time to set it up because I have this adapter, but I put it somewhere safe and I couldn't remember where the somewhere safe was. So I spent about 3 hours on Saturday looking for it, getting very frustrated. And I gave up in the end, and we just made do and cooked on camping gas stoves. Then a friend who's got the same car got power back before us, and so I went round to his house and borrowed his adapter and his portable induction hob. So we've also got a hob now as well. So since yesterday afternoon, we've been up and running, and it's really striking just how, logically, that electricity is very, very useful in life, but life just becomes much harder as soon as you don't have electricity. You have a meal and then you've got to wash up, but you've got no hot water because your hot water is run by electricity. So we've now got hot water again. We could have showers, and just suddenly life felt luxurious again yesterday afternoon after a weekend of struggling around, really.
Do you remember the storm of 1987? Because in a similar way, my dad bought a generator off the back of that you're off power, you realise how difficult it is, and you imagine you might have some challenges like this in the future. But what's nice is it's not a complicated setup. In fact, it sounds like you've had to do very little to get this support at this time.
Yeah, and I think so I've set it up so that when we put all of the services into the house, I did it through like a drainage pipe basically that goes through the external wall and has airtight membrane on one side and wind-tight membrane on the other. And so there's a whole load of cables already going through there, and I can put new cables through and make them airtight very easily. So when we put solar on the roof, that's what I did. And I've now got a permanent extension cable going through there that I've made airtight with a load of spare on the kind of outside side, which is in a porch, in a cold porch. And so if we get another power cut, I just run that to the car, plug it in, and then we've got this extension cable in the house that I can then link up to other extension cables. And I think a second time we'd be up and running in 10 minutes or something. So as a kind of cheap thing, like we already had the car, we didn't buy it because it had this function. And I think there are only a handful of cars that do it at the moment, but it's really useful.
Well, back in the 80s, I don't think we had that many incidents like that big one here in the UK. We wonder whether we might have more in the future. And that's again why it's just handy to have that quick option.
Yeah, and I mean, lots of people will have a much more seamless option where if they've got solar PV and they've got a battery, then you can pay. I think you have to pay extra for it to be able to island from the electricity grid. But once it does that, that's seamless. It would just. I've got friends who've got that locally, and when their power went out, they didn't even notice because it just switched into island mode. But with that, if that happened in the middle of winter, those domestic batteries, they're only like 7 to 12 kilowatt hours. They're not massive. And if you were heating and it was January or February, so you wouldn't be getting much from the solar, you'd quite quickly, even in a passive house, you'd quite quickly burn through your battery. So being able to plug in the car as well, which is a much bigger battery, like our batteries, I think 77 kilowatt hours, that would give us several days of midwinter heating as well as running everything else. And we don't have that home battery on our PV because for various reasons I didn't think it stacked up for our situation. So this is like slightly less convenient, but much better than having no power at all.
Just another couple of questions on this. So, how are you charging your car at the moment? Is that possible through your solar PV?
No, I don't think so. I think unless you have this ability to island, then there's a risk of if one of the tradespeople is fixing the electricity grid, they need to be sure that there's no power in that, and so your PV stops sending back to the grid when the grid goes down. And so we can't charge our car at the moment. So when we plugged it in last night, I think we had 50% battery. So we had half of a 77 kilowatt hour battery, and now we've got 40%. And we did a full reheat of the hot water. The fridge freezer had all defrosted, so that all kicked back in. We did a dishwasher, we did a bread, we did lighting, we did Wi-Fi, we charged a load of things.
We haven't mentioned MVHR though.
Oh yeah, sorry, yeah, no, that was the first thing we plugged in was the MVHR, yeah. But that's a really small energy requirement, but really important because until that happened, well, I'll talk about that in a minute. But yeah, basically I think we've got another 2 or 3 days in the battery, and if it goes on that long, we'll just drive into town and go to a public rapid charger and charge the car back up. But yeah, the MVHR was the thing that I was keenest to get up and running because before that we were just having to have windows open, and so the house was getting comparatively quite cold. I think we dropped to 17.5 degrees, which is not outrageous, but it's a little bit colder than I'd like to be. And it's pretty cold for the sort of temperatures we're having. It's like 12 or 13 degrees outside. We wouldn't normally expect it to be 17 degrees in the house. So it's nice to be able to close all the windows and put the ventilation back on again so the house is quiet and feels warmer instantly because you've not got that breeze and is steadily warming back up to 20. Yeah, that was really nice to get that back on.
Well, today we want to talk about services and specifically how you're doing hot water and heating. Before we get to that, though, can we have just an overview? We've recorded a podcast before, but it was mainly focused on upskilling as you went through the project. So, what are the cliff notes of your retrofit project?
Yeah, so our house is a 1975 timber frame build. It was 1.5 stories, so the first floor rooms were quite pokey and we had a dormer on each side, but the main rooms didn't have a dormer, so you lost quite a lot of space at the eaves in both of those rooms. And We took the whole first floor off and we rebuilt the first floor as a 1 3/4 story house, which doesn't sound like a lot, but it gained us a lot of extra floor space on the top floor. Enough that we've got an extra bedroom, and all of the bedrooms are bigger than they were. So the upstairs is basically a new build passive house, timber frame I-joist sitting on top of the existing structure. That was quite complicated to do structurally. And downstairs, it's a retrofit of a 100 mil timber frame house. So the wall build up is 100 mil studs that we took the plasterboard off, we insulated between the studs. We added another 40 mil of wood fiber insulation board and then an air tightness membrane. And then outside of all that is white rendered blockwork, and there's a cavity between the two and a suspended floor. So we lifted all the floorboards and we insulated the suspended floor. I'm a passive house designer, so I was doing all of the energy side of things. I was also doing quite a lot of the work myself. The retrofit side of it, I was doing myself. The new build was all done by local contractors. And we've been back in since April 2023 and still haven't got everything in for certification. Life has been too busy for that, but it's getting close to that point. We will certify. And yeah, it's been absolutely amazing as a house to live in.
So let's just talk about that transformation. What do you think about it, having lived in the house now for a couple of years, knowing all the effort that it's taken? How are things?
It's amazing. It's hard to remember how it was before because it's just so nice now. But actually having that power cut and having the day and a half of not having any power before I got the link to the car set up was a bit of a reminder of how, you're not thermally comfortable, you're a bit chilly all the time. You can't really dry stuff because there's no reliable ventilation and the house isn't warm enough. And in addition to that, the house before we started had quite serious mold and damp problems. And all of that is completely flipped 180 degrees to the point now where it's really easy to dry clothes overnight, especially in winter when the air is drier. Although I guess, a building physicist, that took me by surprise because I was used to it being especially hard to dry clothes in winter, but that's because your house is cold. But as soon as you have a warm house, if it's well ventilated, the fact that the air outside is colder means that it's got less moisture in it. So you're bringing in drier air, and so everything dries even quicker in winter than it does in summer. So drying stuff is really easy. The house is warm and comfortable all of the time in every room. It's phenomenal in hot weather, almost more impressive than it is in cold weather. Because in cold weather you sort of feel, well, the heating's on, it's warm, you'd expect it to be warm. But in summer, if we have a heat wave, which we don't get that often up here, and they're not as severe as down where you are, but they are getting quite severe. This summer and the first summer that we moved in, we had a week, two separate weeks of more than 28 degrees as peak temperatures in the afternoon. And in those conditions, you walk into the house and the house is 23 degrees and it feels like you're walking into an air conditioned space, but there's no air conditioning and it's that temperature everywhere. It's really, really impressive. And yeah, so just very, very easy to live in, very high quality of life. The air is really clean. I notice it more now. Just walking outside the house, I immediately notice if the neighbour's oil boiler is running or there's a coal fire on locally or a wood fire on locally. I think my sense of smell has improved because I'm used to just having clean air all the time. Going into other people's houses, I noticed that there's that kind of, not that they don't smell, but they're not fresh. Our house is fresh all the time, and that's really noticeable. The best thing isn't the bills, but it's the most quantifiable thing. Our heating and hot water for, well, I've only got 1 full year of monitoring so far. We're about to finish the second year of full monitoring. And that first year was £175 for heating and hot water for a family of five, which is remarkable.
What about beforehand? What was it before you did the retrofit?
So difficult to get all of the things in because a lot of our hot water was a direct electric shower, which wasn't metered separately, and our heating was an oil boiler. I think in current oil prices, like over the past 2 years, we would have been spending about £1,000 a year but that was to be too cold most of the time in winter and to have a mold and damp problem. So we've reduced our heating bill by at least 80% while also massively increasing the average temperature of the house. So, to heat to this temperature would be costing us 2,500, I imagine, in the old house. And and it wouldn't be as comfortable as this. You don't get that level of comfort until you get to a house that needs very little heating.
Now, I wanted to talk about some of the challenges of the project, and I'm imagining this must be right up there as one of the biggest ones, but you had quite a bit of water damage. And I know that this is not an area that you go back to and enjoy talking about, but thank you anyway. So, can you tell us what this part of the project was and how you reflect on it today?
Yeah, so because we took the first floor off, there was a whole period where there was no roof. And we planned that to be in May, which is statistically the driest month on the west coast of Scotland. We obviously thought we might get some rain, but it ended up being the wettest May that anybody could remember. It was really, really torrential a lot of the time. And we did think about this before we started, and we asked the builders for different options. And there was the option of putting a massive tent over the whole structure, but that was £30,000 was the quote for that. And they were confident that they could keep the water out. They said, "Oh, we've taken plenty of roofs off before, and we've managed to keep the water out." But I think the difference was that I don't know every project they've done, but I suspect what they were thinking of was when they've taken roofs off before, they've left the existing pitched roof structure in place, and then it's relatively easy to throw a few waterproof tarps over a pitched roof structure and keep the majority of the water out. But because we were taking the pitched roof off, we just had a flat roof structure. The first floor became the roof, and keeping a flat surface watertight is really difficult and was impossible, basically. There are some ways that maybe we could have done it. Solitex do a product, Proclima do a Solitex membrane that you can put down in advance, and that forms a kind of temporary waterproof layer on a flat surface. That maybe would have worked. I'd have to go and think carefully about it, but it's a really challenging climate to keep the weather out. So anyway, so we basically had it raining inside the house, and I'd already done all of the ground floor insulation. I'd lifted all the floorboards, I'd insulated them really well, I'd done really good air tightness, and then I put the floorboards back in, and I'd done that before the builders came in and started. And it rained so much that all of the floorboards warped and were completely ruined, but also the insulation got wet enough that I was pretty sure it wouldn't dry out before it did significant damage to the structural timbers of the floor. So we once the building was watertight again, we made the difficult but inevitable decision that we ripped up all the floorboards. We took out all of the insulation that we'd put in. We dried the underlying kind of membranes and things out. The insulation under the floor is being held in with a breathable membrane. Dried those out, and then we put fresh insulation in, put a fresh air tightness membrane over the top, and put chipboard flooring down. So that was pretty tough to do emotionally in terms of stress levels. And we had similar things, but less difficult to deal with in the wall. I'd insulated the walls, and that insulation had to come back out, and I had to let it dry. Some of it I had to replace. And then there was some insulation in the detail between the ground floor and the first floor. There was some insulation in there that was under membranes, and we thought it would stay dry, but there was like a horizontal crack that had enough water running down the face that it was just tracking along this horizontal crack and filling up with water. And we cut into one of those membranes, and it was absolutely sodden. So we removed all of that and put it back in as well. So quite traumatic at the time, but useful as a consultant. Like I basically have a rule now that you don't put any insulation in until the building's watertight, because everything else is not very absorbent. So, if your timber frame gets wet, I imagine it's going to dry pretty well once the building's watertight and being heated. But your insulation can hold way, way more water than your timber can, and will suck it up much quicker. So I think you don't want to install any insulation until the building's watertight, except maybe things like tongue and groove wood chip boards that are treated to be water resistant. Putting them on your roof or your walls, maybe that's okay. But the fluffy, soft insulation that you're putting in your walls or your roof or your floor, you don't want to install any insulation until the building's definitely watertight.
And it's interesting that really it was down to cost, wasn't it? If I'd said you can have all that scaffolding and the tin hat for £1,000, you would have done it, wouldn't you?
Absolutely, yeah, 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 yeah. And I'm sure we didn't spend £30,000 on redoing it, but we did have quite
Interesting.
a lot of extra stress. So, in retrospect, I wouldn't have got the hat. I would have just sequenced things differently, I think.
Oh. So hold on,
Um,
take us through then. You're starting again, you're in the same position. What would you do? You want to extend the top part of your house to give you that extra space. What happens
mm.
now in the sequence?
I'd have to check this with the structural engineer because part of the reason I did downstairs before we did upstairs was because in addition to insulating the downstairs walls, we also did some strengthening work. And some of that couldn't be done until the insulation was in. So we added, for example, on a timber frame wall, you have the vertical studs, and they're very strong unless they bend, and so you have a racking board on the outside. And the structural engineer wasn't confident that the racking board we had already was strong enough to take the additional load from upstairs. So we added an extra racking board on the inside as well. And because that closed the cavity, we couldn't do that until the insulation had been on. But actually, we realized that the water was a problem and we stopped putting those boards on. I think we only put one or two on because we realized we were going to have to take the insulation out and let it dry. So actually, those boards didn't go on until the roof was watertight. And similarly, the structure of as I understand it, the timber floor of a timber frame house has important racking strength as well. So I wanted to get that finished before we did upstairs. But in the end, I took all that off anyway. So I think if the structural engineer was okay with it, I would not do anything downstairs, except there were some beams that we added. So maybe do the structural things downstairs that don't involve insulation, then take the roof off, take the first floor gable walls down, rebuild that, make it completely watertight, and then start doing the insulation. And we had a detail where we could only do some of the insulation. Well, it made sense to do some of the insulation before it was watertight, but we could have done that in a different order. So I would have done all of that first, and then I would have said to the contractors, "Thank you very much. I'll do downstairs, and you go away and do a different job for a bit." I think that's the way I would do it.
And if you were doing it for a second time, you know what would have happened?
It would have been beautiful for
Of
a whole
course it
summer.
would.
Yeah.
Right.
So
Now,
it's interesting. I'm working as a consultant on some retrofit projects for very similar houses to what mine was before. And some of them have wanted to do the same as we did upstairs. And in the end, they've decided not to because of cost. So it looks like I'm not going to have to go into that thing of helping them do it better than I did it. It'll just be more retrofitting the existing fabric. But even there, there's some useful stuff. I learned loads doing my project, so there's loads of useful stuff I can offer to people there. But there is some stuff about thinking about when you're going to fix leaks in terms of where the insulation is. But yeah, if I ever have a project again where someone wants to take the whole the whole first floor off the house, I'll have a lot of useful things to say about the weather.
well, that is why sharing knowledge is so powerful, and particularly the honesty level, which I think our low energy community is really good at. So thank you once again for that. Let's now focus on services in your building. What were you thinking, and how are you going to approach the services, given that you're a passive house consultant and interested in all this stuff?
Yeah, so initially I was convinced that heat pumps were the way to go. We need to stop burning fossil fuels, and so we have to have electric heating in the future. And heat pumps are 3, 4, 5 times more efficient than other forms of electric heating. So that was a complete no-brainer. So initially, I started down the route of an air to water heat pump, which is what most people in the UK have. So you have a monoblock, what's called a monoblock heat pump outside your house, that does all of the compression, evaporation, etc. All of that cycle happens outside your house, and it pumps hot water or a hot fluid into the house to warm your thermal store or your hot water tank. So everything happens outside the house apart from where you're storing the heat. And I was put off doing that because local heat pump installers that I spoke to be fair to them, before we'd done any work on the house, so they were looking at a leaky 1970s timber frame house with a very high heating demand. They wouldn't believe me that I was going to get the heat demand to below 5 kilowatts. And I was saying, the heat demand for this house will be under 2 kilowatts, possibly under 1.5, and it is under 1.5. So we need to get the smallest air to water heat pump we can get, and we need to do some things to make sure that it works efficiently. And I couldn't get them to even agree that we needed the smallest heat pump. They said, well, we don't even put those on new build projects. So I started to think about air to air systems. So basically, like an air conditioner is pumping heat from inside a building to outside a building, but they can also pump heat from outside a building to inside a building, and they're similar efficiency to an air to water heat pump, but they're much, much cheaper to install because you don't need radiators or a wet system. It's just what's called a mini split. So instead of having all of the heat pumping going on outside, there's an outdoor unit and there's an indoor unit, and there are refrigerant lines between those two units. And I can't remember where the initial idea came from. It may have been a Passive House conference that I went to in Germany, in Munich. I saw a write-up that someone had done it in an Enefit project in Greece, I think. And then I also became aware that Wolfgang Feist had done it to his, like the original passive house that he lives in. Because I think before they either had gas heating or they had electric resistance heating in that house. I'm not sure which, but he wanted to fit a heat pump to it, and they did an air to air. And I just liked the idea that I didn't have to convince anyone that the house was going to perform as well as it was. The air to air installer wasn't really interested in, they didn't do a heat loss calculation or anything like that. I said I want this one. And they said it'll be this much, and it was £1,500 installed versus, the air to water heat pump was going to be, I think 12,000 was my quote, and that was 5 years ago, so it would be more than that now. Well, the air to air would be more than 1,500 as well, I imagine. But yeah, so it's super cheap to install, but I really like it as a thing for passive house buildings because I don't think it would work in a building regs new build because we only have heat being delivered in one room, and that works because the heat demand from each room is tiny, and it can be met by heat leaking from the dining room into the sitting room and from the dining room up the stairs into the bedrooms up there. That works fine. But in a building regs house, I think you'd just have cold bedrooms and cold rooms that weren't so nice. So it's nice to be able to, you've put all of this effort and potentially expense into building a much better house. It's nice to then be able to save 10 grand on your heating system while getting similar levels of efficiency. And you quite often see passive houses being built with electric resistance heating or infrared heating, which the marketers will try and tell you is much more efficient than electric resistance heating. It might be marginally more efficient, but it's basically the same level of efficiency as electric resistance heating. And they do that because understandably they think, why am I spending £14,000 on a heating system for a house that only needs, 15 kilowatt hours per meter squared per year? But that to me, you're building this house that has a potential to be amazingly good from a climate point of view in terms of its energy use. And then you're putting in the worst form of heating, the most expensive form of heating, and it's pretty high carbon. So you've spent all of this effort building a passive house, and then your heating bills are similar to what they would be if you built a building regs house, and that seems crazy to me. So I think it's got real potential for offering a very low capital cost heating system that works pretty well and is 4 or 5 times more efficient than electric resistance heating. So your bills are, my bills are £175 for a year. If I was on electric resistance heating, that would be 900, £800 a year. It's quite a big difference. £800 or £900 feels like a lot of money. £175 doesn't feel like a lot of money. So yeah, I think it's great as a solution for super low energy houses with some caveats that I can go into.
Are there any downsides? And then maybe you can lead into your caveats.
Yeah, yeah. So, oh, the other upside that I didn't mention is that you've got cooling, and we don't need cooling. The house performs amazingly during heat waves, but there are some exceptional circumstances where we've used it, and the most obvious one is we've had a lot of visitors staying in the house coinciding with a heat wave, and at that point the house does get too warm. And if that's um, if that's normal heat wave weather, that's okay. You can just open the windows at night. But we had one that coincided with really midgy weather. And for those people who don't know, midges are these tiny little insects, flying insects that bite and swarm in Scotland, and they are a nightmare. And I think they're probably more attracted to the house when there's 10 people in it than when there are five, because they hunt by CO2, and so they can smell the CO2. And if the house has got higher CO2 levels because it's got loads of visitors, they'll hone in on it. So heat wave, it's 28 degrees in the afternoon, 29 degrees in the afternoon, really sunny all day, and then you can't open the windows at night and you've got 10 people staying. We did use the cooling then. So that's another side benefit of having an air to air mini split heating system. And in other building typologies where you might not be able to get the overheating risk down as low as we have here, and in a warmer climate like in the south of England, that sort of cooling could be really useful. So that's an advantage of it. So disadvantage is to get heat to, for example, the room where I'm sitting now, my office, to get heat here, it has to flow from the dining room where the heat is being delivered as warm air. It has to flow up the stairs, and then it has to flow along the corridor, and then it has to flow through an open door. And so it's quite reliant on having an open door in order to get enough heat into the room during cold weather. And in very cold weather, it can get a little cooler in here than I'd like it to be. I think if you were going for perfect comfort at all times, then you'd probably have a plug-in electric heater for 2 or 3% of your heating demand, just for those very, very cold days where it's -8 outside, and you've had the door closed. This is my office, but it's also my bedroom. You've had the door closed at night, so the heat hasn't been coming in nearly as much overnight. And then you open the door during the day, but it's not enough to warm this room above 19 or 18 and a half. So in that situation, you might have a plug-in thing that you run a couple of days a year. So that's one drawback. The other is that it's not completely silent. In the room where it's being delivered, you can hear it if you listen carefully. It's noisier than the MVHR, way noisier than the MVHR. You can't hear the MVHR in the room, so yeah, the MVHR is silent. It's about how noisy? About like a fridge maybe, and there is some air movement. So if you were sat underneath it, that would be annoying. So you need to site it in a place that you're not going to be sat beneath it all the time.
Is it normally a living space?
Yeah, you could have it in a corridor, but the space wants to be big enough that you can deliver a lot of heat into it before warming that space to above the set point temperature. Because if you think about, if you had it in a tiny room and you said, "Well, I want it to heat to 20 degrees," it'd very quickly get to 20 degrees and then it would shut off and the rest of the house would stay cold. So, if you had a very open plan ground floor, that would be ideal. It could heat that big open plan space, and then it's delivering so much heat that that heat would get around to the rest of the house fine. But if you've got very small rooms, it won't work so well. And our house is kind of halfway between those two. We've got an open plan dining room and kitchen, and there's an open door to the sitting room, so it's quite open plan on the ground floor. So yeah, you could put it in a corridor, but I think it wouldn't work as well. So you want it in a room that you're using. You don't want it in a bedroom though. It would definitely, I would say it'd be too noisy for a bedroom, especially in a passive house where you really appreciate how quiet the house is. You don't want to have additional noise in your bedroom. So noise and air movement are the two big disadvantages. On the flip side of that, there are some other significant advantages. I prefer to sleep in a room that's a couple of degrees cooler, a degree or two cooler than I like for my office or my living room. And that's pretty common. Most people like their bedroom to be a bit cooler. I haven't lived with an air to water heat pump, but I suspect that would be harder to arrange with an air to water heat pump where you've got radiators in every room. And with our air to air heat pump, we can actually, at night time, we close all the bedroom doors because that's what we normally do for privacy. And if it's winter, we can run the heat pump really hard for overnight when the electricity is really cheap and slightly overheat that dining room kitchen area to 22 degrees, say. But the bedrooms stay 19 degrees. And then in the morning, you just open all the internal doors and that heat spreads out throughout the house. And your already low heating bill is even lower because you're doing a bigger percentage of your heating at cheap rates than you would otherwise be able to do because you can overheat during that nighttime period without making yourself too warm in the bedrooms, which is what would happen if you did it with an air to water, I think.
And the MVHR doesn't move the heat about so much.
It does, but less than people assume. So the most useful thing you can do is leave an internal door open. In our house, the heat is being supplied in the dining room, which isn't a supply room for the ventilation, it's a transfer room. So the ventilation is delivered into the sitting room and then it flows into the dining room and then it is extracted from the kitchen. And so the flow of air via the MVHR is only really moving heat from the dining room to the kitchen, which isn't that useful. And actually, you get much more heat moving through convection from one room to the other if the doors are open. If if you had a situation where if it was like 22 degrees in the room you were heating and it was 18 in the bedroom, which would be exceptional, that would be a really cold night where you've overheated the dining room and the bedroom has got a bit chilly. In that situation, the 22-degree air from the dining room would be warm enough that when it goes through the MVHR heat exchanger, it would heat the incoming air to a little bit warmer than the bedroom. So the bedroom would be getting air at 19 degrees or 20 degrees instead of 18 degrees. And so, yeah, it's adding heat to the bedroom, but at a pretty small rate and a smaller rate than so it's important, but it's not as important as opening doors. And really, the MVHR is super important, but it's not really so important for moving heat. It's so important for minimizing heat demand. So, the MVHR is crucial for the heat demand of each bedroom being tiny, and the heat demand for each bedroom being tiny means that you can heat the whole house by just one heater in one downstairs room. A bigger house, you might have two indoor units, but a house this size, it's 100 square meters treated floor area. That works really well.
And the air source heat pump is always on, always working.
No, it's not. So I have it on a timer and I set it to run harder during cheap electricity, and it's not on at the moment because we've got a power cut. But if the power was on, it wouldn't be on either. I don't have it on at all in the summer, and then just around this time of year, I start to put it on in the nighttime to counteract the water heater, which I'll talk about in a minute. So it's not on all the time, and that's the other thing I'd say that is a disadvantage at the moment, and with my unit it's quite a cheap unit, so the level of control is not as good as it would be with a good air to water system, and the level of automation and being able to control it. I can't control it from my phone, for example. So going away on holiday, I can't set it to be off for 10 days and then to come back on 4 days before we get back or anything like that. But I think some of those problems are probably solved by buying a slightly more expensive unit. The expensive units are still cheap. They're really good value bits of kit. And I have a project to try and automate some of it using Raspberry Pi and Home Assistant, and we'll see how that goes. Because the getting home from holiday thing is actually a bit of a pain because the heat pump is so small and because the rate at which it can get heat from the room it's heating into the other rooms, if you leave it off for 10 days and it's the middle of winter, then it does take several days to warm back up. So at the moment, that's solved by just asking the person who's feeding the cat to turn the heat pump on 4 days before we get back. But it would be good if I could control it from my phone. Yeah, so I think it's a really good system. I think it's a great way of saving a ton of money on a passive house, I'm always looking for those synergies that allow you to save money on doing a more efficient build rather than spend more money on efficiency. And I think this is a really good one for that. And I think I don't know the capital costs of direct electric, but I think an air-to-air mini split might actually be cheaper than direct electric. I'm not sure about that, but it's certainly very cheap. You do have to do something else for the hot water though. So air to water heat pumps, which are what most people have in their houses, most people who have heat pumps have air to water heat pumps. They also do your hot water. An air to air mini split heat pump doesn't do that. It's just warming the air in the house. It doesn't do hot water. So I have a standalone hot water heat pump. It's called a heat pump water heater, and it's basically a 200-litre insulated hot water tank with a small heat pump that sits on top. And normally those are ducted to outside, so it brings fresh air into the heat pump. The heat pump takes some heat out of that outdoor air, and then it ducts the exhaust air back out. So it's not bringing any fresh air into the house, it's just bringing it into the heat pump, taking some heat from it, and then throwing it back outside. And that would be a perfectly fine way to set it up. I've got it actually set up so that it steals heat from the house, so it's not ducted to outside at all. There are some advantages of doing that. It gives you some free cooling in the summer, which is nice. It gives you much faster reheat times in the winter because your heat source for the hot water is 20-degree house air rather than outdoor air, which might be 0 or less. And it is easier from an air tightness point of view. There's various leakage points on the ductwork and the casing around the heat pump that look pretty leaky to me. And if that was ducted to outside, that would be an air leakage path. So mine's stealing heat from the house, which at this time of year is fine. There's more than enough heat for the house to be warm enough. And in the summer, it's useful because it gives you some cooling. And in the winter, it effectively means you have a two-stage heat pump because the heat pump water heater cools the house while the air-to-air mini split is heating the house. And obviously, the air-to-air mini split has to work a little bit harder because there's this cooling demand in happening at the same time. And that's slightly less efficient than if it was ducted to outside. But when you factor in all of the other advantages and disadvantages, in a house that needs very little heating, there's not a lot in it in terms of efficiency. Both options are pretty efficient, very efficient. So it takes air in from the utility room, and then the exhaust air from it is ducted into the kitchen via a silencer. So it throws colder air back into the kitchen. That means in the summer, if I want it to run it as cooling, I can close the door to the utility room and the silencer keeps it quiet, but I'm getting cooling in the kitchen while the water is being heated.
So, is there anything else in the plant room that would be unusual or that's specific to your system and your setup?
Not specific to that heat pump water heater, apart from the ducting, bringing it back to the kitchen, and a couple of holes, a couple of vents that I've cut in the wall behind. There's like a fridge niche in the kitchen, which is in the wall between the kitchen and the utility room. So I've cut a couple of holes in there so that when the heat pump water heater is sucking air from the utility room, that air can be replaced easily because the flow rate is really high. Actually, it's higher than it would be on an MVHR. I think it's 400 cubic meters an hour. So yeah, that not any kit, but there's a little vent in there, a little hole with a vent cover over it, and then there's the duct going back to the kitchen with a silencer on it. So there are some other bits of kit in there. There's the MVHR, there's a shower water heat recovery unit, otherwise just distribution, hot water distribution from our hot water tank.
So, it sounds like a lot of this is going hand in hand. You mentioned as well that you have clients who are on this retrofit journey. So when they come up against this, what am I going to do for heating and hot water? Do you say these two work well together? Or were there any other things when you were exploring around that you were looking at seriously? Or was this a clear winner because of the cost mainly?
It was either this or a hot water or an air to water heat pump. I wasn't going to go for any electric resistance or anything like that. Actually, the cost thing, so the cost thing was a big deal. But it's more complicated than that because you can get a grant in Scotland for an air-to-water heat pump, and you can't get a grant for an air-to-air heat pump. So after the grant, there might not actually be that much difference in cost. But the grant is a bit of hassle to do. Some of the best installers aren't necessarily MCS certified. So doing it the MCS way, which you need to if you're going to get a grant, does hamstring you a wee bit. And those grants won't last forever. And at that point, the price advantage is very significant. Oh, I didn't talk about the price of the heat pump water heater. So that was £2,500. So all in the system was 4 grand compared to 12 grand for an air to water system. So yeah, I mean, I don't necessarily say definitely go for this to clients that are asking about it because it does, like we discussed, it has some advantages over air to water, but it also has some disadvantages. So they need to understand the pros and cons. And there's quite there's a status quo bias, isn't there? I mean, air to water isn't really status quo because it's new to most people, but they will have seen other people with air to water, whereas I'm the only person they'll have seen with air to air. And so there's a bias there towards doing what you know, and most people know having a radiator in every room. So that's fine. Air to water is a fantastic system as well. I'm not necessarily saying that, well, I'm definitely not saying that we should have air to air in every passive house, but I am saying that if you're considering doing electric resistance, then I'd think very hard because it seems nonsensical to me. All the arguments from a climate point of view about passive house, reducing peak demand, so we need fewer wind turbines, less big grid, less backup, all of that winter intermittency concern about passive house being a good solution to reducing peak winter demand, which is an absolutely valid argument. It all crumbles if we build passive houses and put electric resistance heaters in them. So I'm not saying we should never do that. I think there are probably situations where that makes sense. For example, high-rise student accommodation where the demand is very low, potentially no space heating requirement at all often, and you can't put air-to-air mini splits in because it's 15 stories high or whatever. That sort of thing, it might make sense, but for this sort of thing where you've got it's a small house, it's easy to put an outdoor unit in and it's going to cut your running costs by a factor of 4 or 5 and your carbon emissions from using the electricity by the same amount. So I'm really keen on that as a solution to those projects where people would otherwise be putting in electric resistance heating, and some projects where they'd be putting in air to water and then thinking, crikey, I spent £14,000 on a heating system and my heating bills are £200 a year. That seems a bit crazy. Some of those projects, they might look at air to air instead.
And finally, for today, we've talked quite a bit about air source heat pumps, and I think you even mentioned your installer, you had to bring them on site. So this seems to be a challenge with a lot of people finding the right knowledge out there. And what else do we need to watch out for so that it doesn't go wrong and we've still got all this efficiency, we're still cutting the carbon emissions? Is there a final thought?
Yeah, I think for air to water heat pumps, everything that I've seen suggests that you should go with a Heat Geek installer. So there's a program called Heat Geek, which is a training program for designers and installers. And there's a website called openenergymonitor.org, and there's people are monitoring heat pumps in really good detail. And most of the best performing heat pumps on there are people who've done the Heat Geek training. So I think that's a very good starting point if you're getting an air to water heat pump. If you're getting an air to air heat pump, it's slightly more woolly how you do it. I think basically your passive house consultant or designer is going to tell you what your peak heat load is going to be, and you're going to look at how open plan it is and think about whether it's going to work. But it's hard to do hard calcs to tell you that it'll work, assuming that you're likely to have a small amount of direct electric resistance heating as well in the worst weather is probably sensible. But basically, you're just putting in an air-to-air mini split that's a decent size bigger than your peak heat load. So our peak heat load, I think, is 1.3 kilowatts, and our air-to-air mini split is 2.7, and that's the smallest one that was available when we got that, and that seems to work really well. But yeah, I think for air to water systems, I would do some research yourself on HeatGeek. Have got a really good YouTube channel, and I'd ask your installer lots of questions about flow temperatures and buffers and all those things that make a very big difference to how the system performs. I'm actually planning to do the HeatGeek training course myself, possibly not even to use it professionally, or directly professionally, but just to improve my own knowledge of heat pumps and how they work and how to get the best out of them. But yeah, I think if you're going for air to water, that's the key thing to go for.
Well, Ez, it's always good to chat. Thank you so much for going through all this today.
Thanks very much, Ben. It's been a pleasure.
You can get more online in our show notes today, which you can find at houseplanninghelp.com/389. We've got some images of how the house transformed during the retrofit, some of those elements that we've been focusing on today, the air-to-air mini-split heat pump. Also, if you've got a comment or you'd like to ask a question, we'll give you social media links and links to Ez, links to Highland Passive, houseplanninghelp.com/389. My call to action is to check out the Hub. This is the membership community aimed to help you if you're looking to create a healthy, comfortable and energy efficient home, whether you're starting from scratch or dealing with an existing property. So the idea being it's a digital archive. For example, our in-depth video case studies. We spent plenty of time on those, juicing out all of the lessons and giving you the opportunity to go through the process before you really have to do it. So you can sit and absorb what's happened on other projects. We've got Office Hour. That's an opportunity to chat to me, ask the expert. We've already mentioned that Ez pops in from time to time. We've got our courses, which try to map out different aspects. The forum, this is where you can engage with others. And then from time to time, we have guest experts for live training. Want to find out more? houseplanninghelp.com/join. That's it for today. Thank you so much for joining us. The House Planning Help podcast is produced by Regen Media, content that matters.